case. It kind of led to something that was, or it led in a direction which I didn't expect when I initially went to, as you'll see. So, hold on, let me put this on, and then maybe. Okay. All right. So for those who don't know me, my name is TylerHudak. I've been in the information security industry for over 10 years, close to 15 now. I'm the lead malware analyst and reverse engineer for CoreLogic. I teach malware course. Basically, I do a lot of incident response, forensics, and malware analysis. So here's the story. I was contacted by a client, and the client needed some forensic work done. I do want to say up front that I was given permission by the client to talk about this in public, anonymized, of course. So none of the data, all the data that you see in here and that I present is recreated data. Nothing is from the original case. What was going on was a number of their laptops were going over to China on business, and when they were coming back, whenever they would open up Internet Explorer, they would all be redirected to this Chinese website. And so, this obviously sets off flags. You go to China. China's, very famous for its industrial espionage, doing whatever it wants to your computers while you're over there. So obviously, it was a concern to them. What is going on? Why are our computers, when they come back, why are they being redirected to this specific Chinese website? The common link between all of the laptops that were doing this, other than the fact that they had been to China, was the fact that they were all going to the same plant in China, and they were all staying in the same hotel. So their thought was, is there something going on this in this hotel where they're hacking into our computers? How are they doing that, and so on? So this was what I needed to figure out. A couple more pieces of information. This is the website that they were being redirected to, and in fact, when they would go to it, it would actually have their company intranet site in the URL itself. So that was kind of interesting. This server resolves to this IP address, which is China Telecom, which is one of the large China ISPs over in China. All the systems were running Internet Explorer 9. In fact, they had just upgraded to Internet Explorer 9 a couple months prior. And the interesting thing was, if the Internet Explorer cache was cleared, it would fix the issue, or at least it appeared to fix the issue. Of course, until they went back to China. I needed to verify that this was the fix for it, and if it wasn't, how did they fix this? How did they get this malware or whatever's on there off? This is what the Chinese website looks like. It's basically a front end to Baidu, which is like a Chinese Google. It's basically a search engine front end. You go to this and it pops up a crap load of pop-ups, just a bunch of ads and stuff. So who knows really what could be going on in the background? There could be malicious code going on in the background that gets popped up on this. The point was, as soon as they would open Internet Explorer, they would be redirected to the site. So, given this information, I'm going to try to make this a little bit interactive. What do you think is going on?
It looked out on the network for its proxy configuration script.
Okay, so it could have gone out to the network, grabbed a proxy configuration script on in China, and then was redirected. Okay. Somebody else?
Host file, maybe put something in there.
Okay, they could have modified the host file, but in order to do that, they would have to compromise the machine, right? Because you can't just access the host file itself natively. All right, so my initial guts were, there was some type of malware on the system. There was something that was causing this IE to be redirected to this server, or there was something like a malicious browser helper object. If you don't know what a browser helper object is, it's basically a plugin into IE, which can be used to do whatever. Flash is a browser helper object. There's one for PDFs. There's hundreds out there for Internet Explorer, as well as malicious ones. And some pre-analysis recon that I did, in other words, I just jumped on Google and did a bunch of searches, found that there were a lot of discussions where people were getting redirected to this site, but they didn't know how. And they didn't know how to fix it. So this was obviously a problem that wasn't targeted at the client, or it wasn't just happening to the client, which was good. It means it probably meant they weren't being targeted, but still need to figure out what was going on. So I received the 2 laptops. I was given local admin and user credentials so I could log in directly to the laptops if I needed to. And the 2 laptops, the first one was a really good one, had really fast specs, which was good. It meant that I didn't have to worry about waiting for it to boot up or things like that. However, it had a 250 gigabyte hard drive. This is bad because if I need to image the drive, it's going to take a long time to do. And no remediation was done on the first laptop. The guy had literally hopped off the plane the week before and they handed me the laptop. Second laptop, though, was on a slow system. In fact, they told me if you boot this up, it's going to take about 30 minutes to boot up. So it was really slow. Had a small hard drive, which was good, but it also had antivirus run on it and the Internet Explorer cache cleared. So if I was going to look at anything, I would want to look at the first one because it was in the more pristine condition. It would probably have what I wanted to see on it. So because I wanted to look at the first one and the hard drive was so large, I didn't want to image it first. And so I decided to boot it up and perform live response. If you don't know what live response is, it's basically where you log on to a system, or you get onto a system that's running, and you collect volatile information that's on the system. Memory, processes that are running, any open network connections, any handles, you collect the registry a little bit easier. You can collect event logs easier during live response. And what this allows you to do is analyze artifacts on the running system, which you might not see just by analyzing the image. During live response, especially with the memory, you can see how things are running in memory. If a piece of malware injects itself into another process, you're not going to see that from just looking at a disk image. You will be able to see that by analyzing the memory. So this is what I did. The results from the live response from this particular one were a little disheartening. First, memory analysis. I did find some hooks in memory, and what this means was that some processes were kind of redirecting certain system calls in other processes, but these were attributed back to the antivirus that was running on the system. In fact, I think they were running Cisco security agent, and so it would hook itself into various processes, and so that if a process tried to read a file, it would intercept that, make sure that file was okay, or that it was allowed to, and then go on from there. Yes?
I just had a quick question. Could you done a live response in a virtual system of that end?
I could, but I would have had to image the box first. And I wanted to jump into this without I wanted to avoid imaging if I could because it was going to take such a long time. I'll also say, too, that because this was, I guess, and the client even told me this, in the order of, how bad is this, it was towards the lower end of the scale. We weren't worried. We didn't think that anything had been stolen, although we obviously didn't know. We didn't think that this was a mass compromise or anything like that. So I was willing to take a bit more risks forensics-wise. If this was something that was considered higher on the priority scale, I probably would have imaged it first before doing anything. But that was actually one of the plans. We were actually thinking, how could we, I actually wanted them to send me to China, but I knew that was never going to happen. But we thought about ways, all right, how can we send a laptop over there, have them log on to the hotel network and see what happens. But yeah, that was definitely something that we had talked about. But memory analysis, didn't really find anything other than the stuff put in there by antivirus. And that's another thing too, when you do live response, you typically grab all the logs too. Antivirus logs didn't show anything, which doesn't really mean anything, but the process analysis, I looked at those. There were no suspicious processes running. Everything I could validate back to a known file and a known good file. Network analysis, I didn't actually allow it, when I booted it up, I didn't allow it to connect to the internet, but I was watching the network traffic going out. I didn't see anything going out. Nothing that I couldn't attribute back to like Microsoft or it trying to go out to their company site and things like that. The registry analysis, all of the programs that start on boot or when a user logs in appeared normal. I couldn't find anything that didn't check out. Normally, malware has to maintain persistence somehow. It has to start up either when the user logs in or when the system boots up. And usually you can find that during live response, unless there's a rootkit running. I didn't see anything to indicate that there was a malicious program that was being persistent. The IE homepage was actually set to the company's internal homepage, to their intranet page. And I found this in multiple places where the IE homepage was set to the company's intranet page. So it's not like somebody had gone in there and changed the intranet home or the IE homepage to something else. It was set to what it was supposed to be. I did a string search through the registry for the host name and the IP address of the server that it was connecting out to. I couldn't find anything in the registry for those. And finally, you can look in the registry to find all of the browser helper objects that are loading into Internet Explorer. All of those, there were only a couple in there, and all of those I could attribute back to no good files. So performing the live response, I didn't see anything wrong with the system, which was obviously frustrating. You get on there, you know something's going wrong, but you can't figure out what's going on. So live response didn't pan out, so that meant I had to go to the image. Of course, it took 5 hours for the image to complete, but once that finally was done, I jumped on the image, I took the image, I created a timeline of all the files so I could look at the various, when files were modified and accessed. I looked at the Internet Explorer history, so I just grabbed out all the history, ran it through a couple utilities which would kind of break it out for me. And then I did a string search over the entire drive for those, for these two things right here, the IP address and the web address, hopefully to find something. I should say too, it wasn't like I had performed live response and then I didn't start the imaging process until I realized that nothing happened, because once you do live response, it probably takes you about 30 to 45 minutes to collect all the data, and then it'll probably take you a couple hours to go through all that data. As soon as I was done collecting the live response, I shut it down. I started the image. So there were multiple things going on at once. So what I found something interesting. In the Internet Explorer cache, the page for the cache page for the company intranet site was this file, this entire file. And it was quite interesting because this obviously isn't what the company intranet site looks like. And if you look, you see that it's all JavaScript, and it's pointing to the server which it gets redirected to. And if you go through and you do analysis on the JavaScript, you'll see that this actually is what redirects the browser to that Chinese site. And even more importantly, the creation time of this file was around the time that the laptop was in China. So this file was created, this cache file was created when the user was in China. But this leads to more questions. We know that the cache file is doing this, but how did the cache file get there? Is it malware? Was maybe the company's intranet site compromised, that they had VPN'd into their network and this was what was on there? If malware put it on there, where was it? I didn't find any during live response or during the image analysis. Yes?
So if I take another swing at it,
Sure.
they were manipulating the request as they were going back to the original site and then setting the cache time extremely high to click on the box as long as possible.
I'll say you're close.
Wasn't there a company in the United States, weren't they trying to do that on the cable companies, where they'd
Yeah,
redirect
that's where I
you?
was getting the theory.
Yeah.
So
That's what I was thinking.
Actually, China Telecom. So that actually goes back in, or this leads up into the next one really well. So when I did the string search looking for those IP addresses, for that IP address, something interesting popped up in the event logs. When the system was on the Chinese hotel network, and I could tell this due to the timestamps that were associated with the event logs, other host names were being resolved to that same IP address, which was unusual, because all these IP address or all these host names that were resolved to this IP address were not internet resolvable. In other words, if I would go somewhere on the internet and try to resolve this host name, it would come back to this host does not exist or this domain does not exist. In fact, when I went back and I looked, it was the same for the company intranet site. I could not resolve the company intranet host name from the internet. So this led me to think DNS wildcards, which is what you were just talking about. DNS wildcards, if you don't know, are basically records in DNS that allow matching of unspecified host names. In other words, you could take a domain, star.example.com, and set up this DNS record, and so that anything .example.com will get returned, in this case, as the MX record or this MX record. You can set up wildcard DNS records so that if I have intranet.company.com, or I'm sorry, if I have star.company.com, and then I type any host name .company.com, it's going to return something. So it's basically, it's a wildcard for DNS. What it turns out is you can do this for entire TLDs if you own the DNS server. So in other words, I could do this for star.com, star.org, star.net. And what happens is if I type in, or if somebody tries to resolve a host name that doesn't exist against my DNS server recognizes that the domain doesn't exist, I can return any IP address I want for it. Instead of returning the error message, this domain or this host name does not exist, I return, no, it's over here at this IP address. Does this make sense? All right, cool. So I came up with a theory of what was going on, and I wanted to test that theory. So while on the Chinese hotel network, the following happened. The user would boot up their computer, they'd open up IE9. Like I said, they were all using IE9. What's the first thing that happens when you open your browser? Right, it goes to the home page. So what would happen is IE9 would attempt to resolve the company intranet site on the Chinese DNS server. Remember, they're connected to the hotel network. They're not connected in via VPN. So all of their DNS queries are going to the local DNS server, which is owned by China Telecom. The IP is unresolvable, so instead of returning, hey, this IP doesn't exist, the DNS server returns a wildcard entry for its own web server. IE receives this, receives this resolution, or actually Windows receives this DNS resolution, and then thinks that its home page is at this Chinese web server. We don't know where this web server is. It could be the one that they're being redirected to. It could be a totally separate one. So right now we don't know where that is. But IE, thinks that this server here is its company intranet site, so it accesses the server. The server returns the JavaScript redirection page, and the JavaScript executes and gets redirected to sh.114so.cn. This was my theory. Honestly, at this point, I could have gone back to the client and said, this is what I think is going on. There's no evidence of malicious activity there's no evidence of malware on your system, and left it at that. But I wanted to go another step and make sure that this is what was going on. So the first thing I needed to do was figure out where this server was. I knew what the JavaScript looked like. I knew I needed to find this, but because some server on the internet is serving this, I wanted to find that. So I did a couple or I did some more analysis on the system. Didn't find anything to point to an IP address. So I started to do some Google searches, and I found something interesting. Somebody had posted that while they were in China, their Android phone or whatever they were using was not able to download the Android source from the Git repository that they had expected to be able to. But when you look at what it is, they say that what's being returned is this JavaScript, which is the exact same JavaScript that we're seeing on the server. And I got an IP address out of this. So right now, I was thinking, all right, this server 180.168.41.175 is what is serving this JavaScript and what's redirecting everything. If you'll notice, it's very close to, it's on the same subclass C as the Chinese server that's being redirected to. So I knew I was getting close. Right. But I go and I wget that server, see what comes up, and I get this weird JavaScript coming back. I should say too, in order for me to, the important reason for me to be able to test it by going to the actual server is I still didn't know why Internet Explorer was keeping that cache file in there. I didn't know and there were lots of ways I found out that you can tell Internet Explorer to keep a file in cache for a very long time, and I wanted to know the exact method. And so I needed to see the server that was doing this so I could look at the headers coming back from the server. but when I query this .175 box, I get all this back. And it doesn't, when you decode this JavaScript, it doesn't do the same thing. It doesn't redirect it like the other one does. So I knew this wasn't the server. So now I needed to figure out where was the server that was serving up this JavaScript. Fast forwarding a little bit, I did some more Google searches, didn't find anything, so I figured out, screw it. I'm just gonna go across that entire subnet and download every web page that I can find. And so that's what I did. I just wrote a little bash script, went through, and lo and behold, I found it. At .180, it's at least right now, it's returning the same JavaScript. And you can actually still go out to this. The movie that I'll show you in a second, I did this morning, so you can still do this. So now I knew the server where the JavaScript was coming from. So great. So now we can test this out. So how are we going to do this? In order for me to do this, I wanted to make it as close to what the client experienced on the Chinese network as I could. Obviously, I couldn't go to China and test this out, so I kind of had to replicate as much as possible what was going on my local box. So first, I was going to set up a host as IE9 homepage, a host that I knew that would be able to resolve. Then I would set the local box's DNS servers to be the Chinese DNS servers. I was able to actually figure out the Chinese DNS servers for China Telecom. Fortunately, it turns out that the DNS servers are not accessible if you're not in China. So I wasn't able to actually use the Chinese DNS servers, but I figured I can use the local host file to replicate what was going on fairly well, and that ended up working out okay. Once I do that, open up IE, let it be redirected to this web server. Close IE, remove the DNS servers, and then reboot, open up IE again, and see what happens. And this is how I was going to test it. So, movie time. Let's see if this works. All right, so I'm going to, this goes really fast. And so, what's that? So I'm going to pause it at certain points. So right here is the test box that I use. It's Windows 7, a default install of Windows 7, but I did upgrade it to IE9. So that's the only difference. So here, this is just showing you that the homepage for IE9 is my company homepage, www.corelogic.com. It's able to go out and get it. So here the internet options are showing that that is what the IE homepage is set to be, and just so I want to delete everything out of the cache and make sure we have fresh, it's going to go through here and delete everything out. One thing I found out, which is interesting in IE9, is this little box up here: preserve favorites and website data. If this is checked, which it is checked by default, it will not delete any of the cache files related to your homepage or any bookmarks or favorites that you have. And this screwed me up a couple times. I couldn't figure out why it wasn't deleting the homepage cache file when I wanted it to. So if you're doing remediation and you need to get rid of the homepage cache file, make sure this is not checked. So right now it's just going through. It's deleting the entire cache for IE9, so we have a completely clear cache. And then what I'm going to do here is I'm going to go in. I'm going to first what I'm doing is I'm flushing DNS. So all the DNS within the local Windows system is removed. Actually, I did make one other change to the system. I added a registry entry so that by default, the DNS resolver cache keeps things in. Even when you tell it to flush DNS, it'll keep it for 15 minutes. I changed it so that it does it immediately. There's a registry entry you can modify. Then I'm going to the local host file. By default, Windows will use the local host file before it does DNS, as it should. And what I'm doing here is, I'm adding www.corelogic.com in the host file and pointing it to that Chinese IP address that's serving up the JavaScript. This is the same thing as if we were to be pointing it to the Chinese DNS servers. So save that. Exit, and then I'm going to show you, so we're going to look at the DNS that's currently in memory, and we see that it is reading the host file. It does know that it is going to say that that is the IP address for corelogic.com. So next we go in, we open up Internet Explorer. First thing, all right, so watch the URL. All right, watch the URL up above. You can see right now it's corelogic.com, and it gets redirected. What happened in the background was the server, or I'm sorry, IE went out, it resolved to that the .180 box, which served back the JavaScript redirection, which then changes it, forces it to go to the Baidu or whatever you want to call the site. And you can see up in the URL, it actually keeps the page in there. So somebody in China is collecting who's going to the server. They're collecting the URL. This may not be a big deal if your homepage is Google or Yahoo or something like that, but if it's for a company intranet page, you've just now leaked information about your company to somebody in China. All right, so that's great and all, but what happens when I remove the DNS? So I'm going to go into the host file. I'm going to remove that. I'm going to flush DNS. So all the DNS is removed. And then just to show you that, so now this box does not resolve to the .180 box anymore for www.corelogic.com. So in theory, what should happen when I open up IE is that it will try to do a DNS lookup for www.corelogic.com, and it would get the normal address, and you would think that it would go to the normal home page or to the actual server. But as we'll see, open up IE, it gets redirected again. Now, it shouldn't. I mean, you would hope or you would think that it would not do this because it would go out, it would see that the DNS is now resolvable, or it resolves to a different IP address, and it then IE would be smart enough to think, hey, then I need to go out and get a new page. Fortunately, that's not the case. So let me just jump back to the other one. All right. So at this point, I knew what was doing it. I didn't know why it was staying in the cache. And I wanted to be able to tell the clients, this is why it's happening, and this is what you can do to fix it. So I started doing a little bit of research, and it turns out that there's a lot of ways that you can tell Internet Explorer to keep a file in the cache for a long time. You can do things like you can set certain parameters or certain directives in either the web page or in the header for the that comes back from the web server. Those could be a little bit more difficult to do. They're a little bit esoteric. They don't work everywhere. But what I found out was there's actually a lot easier way to do this. Turns out that IE9 uses this algorithm for the cache freshness algorithm. So in other words, in order to determine how long a file is considered fresh in the cache and how long Internet Explorer will use it, it uses this information or this algorithm. Now, I couldn't find this information out, but I'm fairly positive that it'll give you the number of seconds that it's valid. I could be wrong on that, but I don't think I am. So if we look at the server times that are returned from the server that gives us the JavaScript redirection, see two interesting things. So this is the date when I requested it. This is the last modified date. So it was last modified almost 11 months prior. So what happens is when IE9 sees this information and it uses that to generate how long that cache file should stay is valid, this is what we get. From here, this is the algorithm, just substituting in the dates, converting the dates to their numeric epoch values, and we get 2 million. It should be that cache file should be considered fresh for 2,879,706.8 seconds, which is about 32 days. So in other words, IE9 will always use that cache file for 32 days. It will never go out and it will never check for a newer page for 32 days. So it turns out this is why as soon as the client would come back, they would open up Internet Explorer. Internet Explorer would see, hey, the cache file is valid for another 30 days. We're just going to use the cache file instead of going out and requesting to see if it had changed on the web server since then. I'd actually done a number of other experiments where I was actually using Process Monitor and having a sniffer running just to see if it would actually go out and do a DNS request or do anything else in regards to the cache file, and it didn't. If you do this, you'll see Internet Explorer open up. It'll go to the cache file for the homepage, which is really easy to find because if your internet homepage is something like intranet.company.com, the cache page is going to be intranet_company_com. It would never go out to. I never saw a DNS request. I never saw a web request go out for the homepage. It would just automatically open up that cache page. It would do its internal calculations to see how much longer it had to be fresh, and it would just use that. So as it did this, of course, the cache page had all this redirection JavaScript in it. So that's why we were getting redirected, even though they were no longer on the Chinese network or they were no longer anywhere else for that, or even though it wasn't the valid the server or web page. That makes sense. I kind of stumbled through that, I think. Cool. All right. So lessons learned from this, at least for me. Not everything is malware. This is obviously kind of disappointing for me because I'm a malware guy. I want everything to be malware because then it's even more interesting for me to look at. But it wasn't. Not all attacks are malicious. If you look, this attack didn't use a vulnerability. It used what Internet Explorer is meant to do. And in fact, I think you had mentioned it, places like Time Warner and Comcast do these DNS wildcards. And they redirect you to another, to like one of their pages that may help. I think it's supposed to help you figure out, you mistyped something, and they're telling you, hey, you mistyped something. But they're doing it the right way. They're not setting a last modified time of 11 months ago, so it stays in your cache forever. This attack, technically wasn't malicious, and you didn't need a vulnerability to attack someone. I think what's going on with China Telecom is that they're just trying to redirect people to their own servers. And it's China, so they have the Great Firewall, so I think they probably have a little bit more leeway in order to do it. People aren't going to complain as much. But this time, the user was only redirected to a Chinese search engine. Imagine what you can do as an attacker. If I owned a DNS server and I knew that your company intranet page was not resolvable, I would grab one of these DNS servers and I would start redirecting people who are trying to go to your intranet page to something that I owned, and set the last modified time to something really far away or really far in the past, so that my code now loads into your IE homepage. An interesting thing too is think about how you have IE set up on your corporate laptops. Think about how you have the homepage set up. Is it set up in the normal security zone for the rest of the internet in IE, or is it set into a security zone where it has more privileges? It's probably going to be in one where it has more privileges. So now I can inject my own code into something on your system which is going to run with higher privileges than somebody else, or than another web page. All right, so, yeah, don't go to China. So in IE, when you set bookmarks or you set, in IE, you have different security zones, right? You have one which is like for the normal internet. I'm not going to let any of this scripting run. You have stuff which is like really restricted stuff, and you put a domain in that. Don't ever let anything run on this, or it runs with lower, I guess, privileges within IE. But then you also have the opposite side where you have zones which are where you put trusted websites, which you allow to run more types of abilities in scripting. In my experience, the company intranet site is in that trusted zone. So as this cache page loads up with whatever code, or in this case, the code that the Chinese JavaScript put in there, it's going to run with those higher privileges or with those more capabilities than what it normally would. As an attacker, just think about everything that you can do with this. I've been on penetration tests or social engineering penetration tests where we knew that the internal domain for that company was not registered on the internet. So we would actually go out and register the company's internal domain on the internet, and then we would just wait for everybody who wasn't on the company intranet to open up their browser or open up, turn on their computer when they weren't, when they were at home, and all of that traffic would come right to us. And you can do lots of different things with that. You can force them to go to certain web pages. You can, redirect them to other places. You can even get credentials coming in through NetBIOS, and just depending on how everything's set up. So there's a lot of stuff you can do with this. And it all goes back to controlling the DNS. Right. And that's one of the suggestions that I made for the client was, well, it wasn't really a suggestion. I actually, it wasn't in my official report. I didn't say, because the easiest way to fix this is to hard code your DNS servers on your laptops. But the problem with that is, if I hard code my DNS servers, then they're going to be on the internet. They have to be on the internet. And so an attacker could figure out that you have DNS servers there and start querying all your domains and all your host names, and you could potentially have information leakage. So it's a risk reward. I mean, do you want your internal DNS to be on the internet, or do you want this to happen? Right, and that's how these are set up, but that's why this happens as well. It's the user wasn't connected to the VPN, so as soon as he opened up IE, it went out and did the DNS. But you're right, you could hard code something like Google DNS or something like that. But the problem is, I don't think you can query the Google DNS servers from China. The final thing is, look everywhere. When you're doing forensics, when you're doing incident response or a forensic analysis, oftentimes it's not going to pop out right away what's going on. It took me like 3 or 4 days to figure out what was going on in this. And it was just, I would have to search for another thing, and it would pop up another clue, and I'd look in another place, and eventually I found all of this information. So, yes, sorry.
So if you would have negotiated a VPN connection before opening IE,
then this would not have happened. Right. But the interesting thing too, like I said, when I looked in the event logs, all of these other hosts for services that were starting up on boot, like backup services and things like that, were getting this IP address for their host names because those weren't resolvable. So that happens, all that stuff gets started before you even get the chance to launch your VPN connection. So it's almost like it's a no-win situation here. If you want your corporate laptops to travel, there's going to be some of this. And I think this is an extreme situation. It being in China and them being able to control as much as what's going on, but
what do you think about the potential for companies to start having people having like hotspot intermediary hotspots that they carry with them when they're moving around, and that plays an intermediary role between like a hotel network or whatever, and that way you could potentially cut off some of this traffic before it starts happening.
I think that's a great idea.
I don't see it very much, but
No, and
mitigate the issue. Maybe it'll come to that. I don't know.
Not in China.